Hello everyone, 4.9 quadratic systems. So first, we have a quadratic and the shape looks like a U. So if this is negative right here, that means it's going to be pointing down. And just like anything else, it's on a two grid system, meaning X and Y. However, we can still plot this on a one-dimensional, meaning a number line. First thing I'm going to do is find my zeros. First thing I'm going to do is factor. So I can take out a negative out of all of these, which would be negative 1, x squared. This becomes minus 5x minus 6. And I'm going to factor that, and I have negative 1 on the front, x minus 6, x plus 1. Because remember, multiply to get negative 6, add together to get negative 5. Set those both equal to 0, you get your zeros at x equals 6 and at negative 1. So I plot those on my number line. Negative 1 should be first, 6 should be second. So this is going to be in closed circle, because if I go back to this, it includes those numbers. So I'm going to include that number and include that number. I want to see, is it shaded inside? Because these would be my two zeros. Is it shaded inside or is it shaded on the outside? If it was shaded on the outside, notice how it would be pointing out. Or is it shaded in between? So that's really what I'm dealing with. Is it an or statement or is it an and statement? So you have to test a point. The easiest point to test is always 0. 0 would be located right there. We want to see if that's a true or false statement. So I plug that into my equation, I would get this out. If I plug 0 into this x, if I simplify, I get this. Is 6 less than or equal to 0? No, that is false. So since that's false, that means I'm not going to shade in between, but I'm going to be shading out. So right there would be my answer. I want you to pause the video right now, and I want you to do B by yourself. So you should have gotten your zeros at 3 and 4. So here, there's no line, so these will be open circles. I'm still going to test 0, because actually that's the easiest one to test. So I plug 0 into the equation, I get 12 is greater than 0. That is true. 12 is greater than 0, so I have to make sure to shade where that is true. So since I'm shading out here, I'm shading out here. You can always test each and every point if you wish to. Go for it if you want. I want you to try to do C and D by yourself right now. So first, looking at C, you should get your zeros at negative 3 and 3. Remember, negative 3 is smaller on the number line, so it should be first over here. If I plug 0 into my equation, negative 9 is greater than or equal to 0. That's false, so I'm shooting out. And for 2, I can factor out a 2 and an x, leaving me with my zeros at 0 and negative 2. I cannot test 0. 0 is one of my points. I do know that this both will be open circles because I'm not including it. It's not or equal to. So I plug negative 1 into my original equation. I get negative 2 is less than 0. Well, this is a true statement. So since this is true and this is where negative 1 would be, then it would be shaded in between. So your second part of 4.9 is solving a system. Remember, a system is when I'm solving it, where do they cross? And so far we have done a system if there were two lines, they would cross right there, or we've done a V, and if it crosses someplace. Now we have a parabola and a straight line. So if I'm dealing with that, whoopsie, sorry guys, then that means I'm going to have two different answers. So how do I figure this out? Well, it says y is equal to. So I'm going to use substitution. I'm going to put, this is what y is equal here. Here's my y. So I can put x plus 3 is equal to x squared plus 6x plus 9. And I want to set that equal to 0. So I want to move over my x and my 3. So I'm going to subtract my x and subtract 3. So 0 will be equal to x squared plus 5x plus 6. So now I want to factor that. What two numbers multiply to get positive 6 and add together to get positive 5 would be x plus 2 and x plus 3. So now I can set that equal to 0, and I get x is equal to negative 2 and x is equal to negative 3. So I have two different answers here. So actually what I'm going to do down below is already write out these points, because I know that at negative 2 and 3, those will be my two answers. I'm going to plug it back into this equation because it will just be easier. Negative 2 plus 3, if I do that in my head, I would get a positive 1. If I plug negative 3 into my equation, negative 3 plus 3 is 0. So if I were to graph those two equations, I would get negative 2, 1, negative 3, 0. So right now, I want you to try to do this one by substitution. So first plug this in for y. So if I plug or opposite x minus 3 in for my y, because that's what y is equal to. Add the 3, add the x. I factor that. What multiplies to get negative 9 adds together to get 8. Be a positive 9, negative 1. Solve for that, set that equal to 0, get negative 9 and 1. So now those are my 2 points. If I plug negative 9 to the equation, this is opposite x. So opposite negative 9 would be a positive 9 minus 3 would give me 6. And opposite positive 1 would give me a negative 1 minus 3 is negative 4. So these are your 2 points. I want you to try C and D by yourself, both of them, because you're amazing. So you should have gotten x plus 6, x minus 3. So my zeros are at negative 6 and positive 3. So when I plug those negative 6 back in, I get negative 11. If I plug 3 back in, I get 7. So these are the 2 points that those two graphs separate. X equals to y, so I just have to plug x in for my y right here. Subtract the x over. Factor this x plus 36 and x plus 2. Solve it. X equals negative 36, negative 2. Because x and y are equal to the same thing right there, since I know x, I know y. And there you have it. See, easy peasy lemon squeezy. I hope you have such a great, grand, wonderful day.